Hello everyone. In this short tutorial, I will show you how to create a simple virtual ground circuit with the Arduino prototype shield contained in your lab in a box. We will look at these three representations: Multisim representation, the Tinkercad representation, and the Breadboard circuit. First of all, take a look at an op-amp schematic that you may be already used to. We know the positive and negative non-inverting and inverting terminals, and we also know about the output terminal of the op-amp. But pay close attention to the VS plus and VS minus. These can be VCC or VEE, but for this illustration, these are the positive and negative terminals that serve as input to the op-amp. An op-amp is an active component. That means that it needs a power supply to do any amplification or any work at all in a circuit. So how do we realize that? Because we do not have a positive and negative power supply, and there are no batteries in your lab in a box. Well, that is why we're talking about the virtual ground. A virtual ground can be described as a node on a circuit that is maintained at a steady potential, which is assumed to be zero, without actually connecting that potential to a ground terminal. So in summary, we are making up or creating a ground terminal without actually connecting it to such. Okay, now let's create this virtual ground circuit using Multisim. I'll be using Multisim Live. It is free and available to anyone on the internet. Okay, let's dig in. So let's fire up Multisim Live. We'll name our circuit, and then we'll place the DC power supply, 5 volts. We add our 2 resistors, and we'll make up a voltage divider to divide the 5 volts into 2.5 respectively. So we connect the 2 resistors together, right, and connect it back there. Okay, let's try again. Let's make it straight. Okay, good. And now we'll connect the op-amp. All right, connect the positive end. That will be terminal 7 on our LM741. Connect it up to the positive end, then connect the negative end like so. All right, then divide the 5 volts into 2. All right, and then that will be the voltage follower, and it serves to isolate any noise or make it stable, so to say. So we change the resistance to 10K respectively. And the probes, so we use red for the positive 2.5 end color, and we'll use the closest thing we can get to black here for negative 2.5. The virtual ground will have green color. All right, so the voltage follower serves to isolate noise from any circuit. So now let's run it. So you can see here 2.5 volts each, and the virtual ground is at 0. All right, take a look at the graph. Red, green, and purple. Great. With that out of the way, let's move on to Tinkercad, where we'll create a virtual breadboard assembly. First, we start with a nano breadboard. Alright, just a small one. And I'll need my Arduino. So I need my Arduino. Okay. Right here. We need my operation amplifier. Over here. And movie. Yeah. That 2. No, that should be 3. Remember? Yeah, this is okay. Yep. So what we can do next? Remember, the voltage follower is from 2. To 6. We shall color this red, green, and then we have, and then for the remember, then we have the power supply for terminal 7, that one, and then we also have yes, what is here? Actually, I might just put this here. This, I will color this black, and then this one is there as well as a power supply, this one, and then so what about the probes? How do we know that we're actually getting virtual ground? So we'll look for an oscilloscope. No, actually, let's look for a multimeter, and we have 2 of them. This one is voltage and this one is voltage. So for the virtual ground circuit, we'll actually have, so what about the probes? The probes we have here and here and even here. Remember, one is positive with respect to the ground and one is negative with respect to the ground. So we're going to look for multimeters, 2 of them. Probably have one here as well. And so for the positive one with respect to ground, that one might make that here, and then because this is the virtual ground, and then for the negative one with respect to the virtual ground, we might Yeah, we can either put that here, which is something we can do. And then it might be a bit messy, but I just don't want to confuse them with each other. So I can choose to make that green if I want, and make this green if I want. And this is positive with respect to that, so I could put that green, and I can make this red. So if all goes right, if I simulate, yes, we'll have a positive 2.5 volt here and a negative 2.5 volt here. And so this will serve as our power supply for any op amps that we want in our circuit down the track. So that concludes the Tinkercad representation of a virtual ground. So what we're going to do now is move to the third part of our presentation. Remember, we're going to look at the breadboard circuit for a virtual ground. So to do that, I have a setup here. We're going to be trying to mimic what we've already created here, and if I can just drill down to see what I have here. So I have a prototype shield, and this sits on the Arduino. What I might do is demonstrate how you see how this sits right on top. So there's a ground, there's 5 volts, and all the pins are transferred. So everything is carried to the top. So to start, we're gonna place our op amp. So I have my LM741 here. I have my LM741 with a dot facing the top. Somewhere here, that's fine. And then I have 10k resistors. I might check them here. Okay, I might check them. So you see what I'm dealing with. That's 10k. The reason why we want them to be equal is we want them to have an equal value of 2.5 volts across each of the probes. So if I bring that back, I'm gonna put I'll start with my voltage. Remember, this is the first, so start with my voltage, and you see the 5 volts here. So one leg starts volts. Alright, put 5 volts here. Then I put one of my resistors I've already pre-cut. Put the resistor here, and we want to make sure that we have terminal 3, so terminal 3, and then resistor 2 here, and that will be terminal 3 coming down here. Good. What I might do is I don't have black color, so I'll use brown, something as close to black. So put my black here, and what I'll do is I'll put my black here, or I might just have because this is all ground. I might decide to use this ground. Okay, that's ground. So I can then join this ground to this ground. So what I will do is cut this. To make it short, I could also just get my ground direct from here and put it onto pin 4. Okay, and I'll need a few things. I'll need to power pin 7 from here. The power pin 7 from here. Pin 7. Then I also need the the voltage follower. I need the voltage follower. So to do that, I've pre-cut. So that is going from pin 2 across to pin 6. Good. So if you trace the circuits, the positive end is all done, the negative or the common end, the ground, is done, and then the voltage follower is done. So what else do we need? We need to get our terminals to measure 2.5 and minus 2.5. So how do we do that? Well, it's simple. What we can do is use some pins. This is our virtual ground, and that can go onto any other circuit you want to have, like an inverting amplifier or non-inverting amplifier or a differential amplifier. That's your virtual ground. And then these are our probes. Remember our probes we talked about earlier? So these are our probes. So this is positive with respect to this virtual ground. So to make it easy for us to measure, our values, our 2.5 volt values, we just plug these pins. Remember, you plug your circuit before you plug into your computer, and we want to be safe. So I'll plug the Arduino to my computer. Okay. So the Arduino is plugged, and what I'll do now is I'll connect my multimeter and put it to DC. So we know that this is positive here and negative here will give us 5 volts, and it says here at the bottom you got your 5 volts across there. Then what about your 2.5 volts? Yes, so it is positive with respect to the virtual ground, that is 2.5 volts or 2.55. We'll take that. It's really relating to the values of your resistors. And what about minus 2.5? You put your negative on the ground terminal, and you put your positive. Put your positive on the ground terminal and your negative to the virtual ground. That's 2.56 and 2.56. We'll take that. So I wish you all the best. It means now that you can now connect this to other breadboard circuits, other differential amplifiers, inverting amplifiers, or any other circuit you want to make. Jump in off there. Thank you.